Good morning, good afternoon, or good evening, wherever you may be. Let's get started here. If you could please we're going to do our typical webinar move here. If you could just let me know that you could hear me by hitting your raise hand button. Awesome, fantastic. Well, let's get started then. All right, welcome to Inedo's webinar on the 5 methods to migrate your NuGet packages. For those of you who don't know, Inedo is a DevOps software company located in Cleveland, Ohio in the United States and in Tokyo, Japan. And we specialize in self-managed tools for Windows primary shops. I am your host today, Elsie, and it may surprise you, it may not. I am not a developer, but I do work very closely with our developers, and I did so to create our .NET 5 content. NuGet is such a fundamental part of .NET. And now that .NET 5 is out, we ourselves wanted to know the best way to migrate our own private NuGet packages inside Inedo. And so we wanted to share what we found with you. So with the rest of our time today, we are going to talk about each of the 5 migration methods in detail, and I'm going to show you some of this stuff in action inside some CI/CD software. .NET 5 can't use your first-party .NET framework libraries and vice versa. So you can't just use them as is. That becomes a bit of a problem. But throwing them out and starting over is a gigantic waste of time, because in many cases, small tweaks will change them just enough to do the trick and make them functional. But how do you decide what small tweaks to do for each of your packages or your libraries? We came up with 5 methods. They are abandon, update, fork, multi-target, and bridge. These are in order of difficulty, so I'm going to start with the easiest. And that's abandon. Certain .NET Framework technologies can't port to .NET 5. These are technologies like WCF, WF, ASP.NET, web forms, and a little bit to do with WPF as well, but we could get into that later if you have questions on it. Identifying these libraries that can be abandoned at their end of life is an important part of your .NET 5 migration journey. Basically, you just take care of them as you normally would a package until it reaches its end of life, doing no more than minor patches or bug fixes. That's abandoning. Next, we have update. So let's say you're buying a new pair of jeans. You don't throw out your other jeans just because you're getting a new pair. Updating is like buying the new jeans and keeping the old ones for just in case. And anybody who's like me, who's gained a little bit of weight during COVID, can probably relate to that feeling. You update your NuGet libraries to target .NET 5+, but you use a big version number jump to leave room for if you need to roll back and make updates to that older version. So using a big version bump, for example, from 2.6 to 5.0, communicates to consumers that there is a significant difference between those libraries. But perhaps more importantly, it gives you enough room to version between that original version and the updated one, so that in an emergency situation, you can essentially go back in time and create a new version of an old library, essentially forking after the fact. What's forking, you ask? Well, that's our next one. Forking is essentially like clicking File Save As on Microsoft Word. Forking copies all the same source code into a separate repository, so you can have the .NET Framework library keep going, and then use that same library as the starting point for what will become the new .NET 5 library. You do the same thing you would do as if you were updating, but instead of just keeping the framework library for just in case, the framework one and the .NET 5 one are both going to still be in use. So how to update and how to fork. The basics are that you will fork the current library, copying the source code and renaming the project repository similarly, for example, like utils and utils core. And then in the fork, you change what Visual Studio will target. So if you tried to compile after this step, you would very likely get errors. So to avoid that, you fix the errors created by the retargeting and test until you are error-free, and publish that library then under its new name. Pretty easy. The next one is getting into the more complicated territory, and that is multi-targeting. This is sort of the buy one, get one free model. This is my favorite analogy. So I bought myself a copy of the Star Wars DVDs. And inside the package was both a DVD and a Blu-ray disc inside the same package. This is what multi-targeting is. It's one package library with targeting for both versions inside of it, letting Visual Studio use whichever one is appropriate. So in my case, if I didn't have a Blu-ray player, I would just pop in the DVD. So if your library needs to use .NET Framework, it would use the .NET Framework files. If it can use .NET 5, perhaps it would use those files instead. This is a very, very convenient method, but it is difficult. So you want to make sure you're 100% confident that you're doing this right before you try it. So make sure you carefully follow Microsoft's documentation if you want to try that. And our last method is bridging. Oh, but let's talk about multi-targeting. Multi-targeting is where you're going to configure your project to compile and build multiple times, one for each of the platforms you want to target. So .NET Framework, let's say 4.5.2, and .NET 5. And then you'll build a NuGet package out of all those assemblies. So the two targetings are inside the NuGet package. Now let's talk about bridging. We say bridging is the most difficult only because it's a temporary solution. .NET Standard 2.0 at this point is deprecated, but if your code is compatible with it, you can use it as a bridge to get you from one .NET Framework to the other, .NET 5, with quite minimal work. So another patented LC analogy, maybe you primarily speak Spanish, and I primarily speak English, but we both know Italian. We can communicate in Italian and do an okay job getting by. That's .NET Standard. It can get the job done, but it does leave a lot of room for improvement, and it's only a temporary solution. So today we've discussed abandoning, updating, forking, multi-targeting, and bridging. As I said before, we discovered these because we've had occasion to use all of them inside Inedo for our own private NuGet packages. This brings up two essential points for us to cover next. The first is, how do you pick the best option? Well, the best option is unfortunately unique to each package and each library. You have to treat it that way. But there are a few things that you can do to pick that best option, and they are things like assessing how many applications use each library, assessing when, if ever, it will need to migrate to .NET 5, ruling out methods that will not work with your code. For example, maybe you can't use .NET Standard, so there goes bridging. But for every single method, we come to essential point number 2, which is that semantic versioning is the single best practice for NuGet. NuGet itself is built on semantic versioning, which is the major, minor, patch numbering system that you see in version numbers. Semantic versioning is so important because it reduces confusion, it avoids duplicate work, and it prevents production unready packages from going to production and helps you avoid dependency hell, right? Which is where we use that term a little bit lightly. It means using a package that means using its dependencies, which you may not realize are incompatible with other versions, and then you change it, and then you can't figure out where the break is. Dependency hell. Also, this avoids the problems of specialized or esoteric naming conventions. How do I know which latest file is actually the one I should use? Semantic versioning is mathematical, so it's very, very difficult to get confused on. So how do we enforce semantic versioning? Well, we do that with repackaging. Repackaging creates a new package from an existing package using exactly the same content, but changing the name. So for example, build 6 may yield version 1.0.4-CI, continuous integration for testing. Once someone tests it and approves it, it gets re-released and repackaged and re-released as 1.0.4. that will be the one that can go to production. No matter which of these versions you use, using repackaging to enforce semantic versioning is the way to do the job right the first time because it enforces package immutability, the general best practice rule that states that once a package is created, it should not be altered. So let's see this in action. It would not be a good use of our time together today to show you applying one of these 5 methods because, as I said before, every package is unique, and of course, also because I don't know how to do the technical parts of that stuff. But what I do know is how to use our software automation tools, BuildMaster CI/CD and ProGet package repository. So I am going to show you that at this point. And so what I have here on my screen, and I will display that in just a moment, is a version of ProGet package repository and BuildMaster CI/CD. And you do need to have the .NET SDK installed for this to work. I chose to put the .NET 5 one on my instance of Lightsail, but .NET Standard at least 2.0 would work just fine. So we're going to start in ProGet, and if you ever get lost during this tutorial, just check out that icon at the top. The orange with the X is BuildMaster, and the blue with the hex is ProGet. So we're going to start by creating a new feed in ProGet. And please forgive me for not looking at you. My second monitor is over on the side. I'm going to start by picking a NuGet package feed, naturally. We are going to name it tutorial test. Let's just call it tutorial. And it's going to be a private feed. All right. So we have created it. What I'm going to do now is copy this API endpoint because I am going to need that next. But the next thing I'm going to do before I head over into BuildMaster is I'm going to create a new API key. So I navigated to my settings, and now I'll click API keys, and I'm going to create a new one. And we're just going to call it API key, let's call it tutorial key. And I'm going to copy that also and save it for later. We want to give it access to repackaging, and we also want to give it access to the feed API. Okay, and if you wanted to make it so that you limit the users on it, you would fill this impersonate user out. Otherwise, it becomes a global API key. And you also could leave this blank for ProGet to just generate one for you automatically as a random string of letters and numbers. But for the sake of our tutorial, we're going to use this. So save API key. All right, so let's head over now into BuildMaster. So I am going to create a new build in BuildMaster using our application templates. So create application. The application templates are just pre-made templates for common types of builds, common types of applications that you may use to just get a common setup for those on there. So we're going to go with tutorial application and create. And what this does is it applies this application startup template, giving you the things that a NuGet package, a NuGet application would require for you to change as you go. So you'll see we have a few shields up here that we need to take care of. So we're going to start with secure resources. And I need to create a new secure resource here. So I'm going to go to create secure resource, and I'll scroll down to NuGet. And then I am going to not do what we think we would do. We're not going to fill this out first. We're going to start by going to create. And I'm going to use API key and token. Now I'm going to put the API key in that I just made. And now you know that we would never just use the exact same API key as the API key name. But in this case, since security is not the point, I am going to just use that. It is for our tutorial application, and so we are good to go. We're going to save our credential. No, thank you. All right, now we're going to select that tutorial key from the dropdown, and we'll go ahead and name this guy as, well, let's call it tutorial. Let's just call it tutorial key again. All right. Now we are going to make sure I did everything right. No, we didn't. We have to put in our API URL. So we've got our API. This lets ProGet and BuildMaster talk to one another. If I forgot that, it wouldn't work. So let's save that resource. All right, so we have our secure resource. If we click Application Setup, we go back over to our Application Startup template, and we see that that first shield cleared. All right, so now we're going to get our secure resource name in here. We are going to use, let's see here, what did I call it? Tutorial key. Okay, save. And package name. Now, what we're going to do for the package name is something special. Because I'm not going to show you a real package, I'm going to show you our test package. I'm just going to copy it from right here, this profitcalc.NuGet, which we have set as an example for you. And I will put it here and save. And now all of our shields are clear. We are ready to go. All right, so let's create our new build in BuildMaster then. Create a release. And since this entire presentation is about the importance of semantic versioning, we will start with 1.0.0 and create a release. And then create a build. And here we go. BuildMaster is running that build for us. And the execution has completed successfully. Awesome. So we have our nice green check mark. Now what we're going to do is go back into ProGet. And I'm going to go to my feeds or my packages here. Actually, I could go there. And profitcalc.NuGet package has showed up, and there it is, a CI version, a continuous integration version. You'll also notice, just in case someone on your team was a new person or someone who doesn't really know how to do development, was taking a look at this package, it says CI, but it also says pre-release. It's there just to make sure that someone doesn't mistake this for something that can be used in production. All right, so let's go and push it back through to show you what it looks like once it gets to a stable version. So I'm going to go ahead and deploy to RC, release candidate. We're going to go ahead to deploy to RC, and it will run through. And let's pop back over to ProGet here. I do want to point out, and if I refresh this page, it will show us our RC. There it is. What you can do here is when you click into your version, you can view the files inside the package. By going to the Files tab, you can view the metadata, which is a very important part of a package versus an artifact that you could see here, and all of these other pieces of information which are available inside the package when you click its link. So back to BuildMaster, we see we have a warning shield here on our release. Issues have not yet been synchronized with the application's issue tracker. This is a known error that we purposely put in the tutorial application so that you would have the knowledge that you do in fact want to associate with an issue tracker. So since this is an okay error for us to have, I'm going ahead and click force LC okayed, and we will force promotion. And it will push its way through. All right, and so if I go back to ProGet and I refresh, we will see our stable version has showed up, 1.0.0. Nothing on there, no pre-release indicator. We can also, if you're just wanting to make extra sure you don't use the wrong package, you could also hit this hide pre-release button, and then you will only see the stable versions. So this is as easy as it can get, easy as it can get. And we have our stable version ready to go inside of ProGet. So back in BuildMaster, we can always re-release if we needed to by going to Overview and creating a new build, or by looking at our latest released builds. This pipeline is just our very basic pipeline. It's what we have in there for the NuGet CI/CD application. The great thing about BuildMaster is it is highly customizable to do what you need it to do, whether it's an automatic promotion to next once it passes the sniff test, whether it's needing a manual approval for each stage, whether it's actually avoiding letting pre-release versions even get pushed. You want to customize BuildMaster to do what you need it to do. We don't want you to have to do things our way. So from here, basically, you could set these tools up to your heart's delight. But it really is that easy. That's all I wanted to show you today because it is that easy to do. So now it's time for questions. If I can answer questions for you, I would love to. And while I'm waiting for any of you to type your questions into the question bar, I do want to answer a couple questions that came through from folks who registered early. And the first one was, do I have to have both of these to do repackaging? No, you technically do not have to have both of these tools to do repackaging. But ProGet is the one doing the work, but BuildMaster is the one putting the repeatable process on the work or around the work. So BuildMaster is sort of the rigor around the doing of the thing. So by using BuildMaster with ProGet, you're getting that repeatable process, but you're actually getting a lot more than that. You're also getting quite a few other features that you saw in passing when I worked with you today, which is a NuGet specific application template, shared pipelines that let you see things even if you're not able to edit them, and configurable approvals that would actually tell BuildMaster not to let applications use pre-release versions to try to go to production. Another question that I got early that I did want to cover is, does this work for NuGet packages that we get off of the gallery? That's actually not, it's sort of a trick question because that's not a necessary thing. The third-party packages that are in NuGet.org are already stable versions. So anyone who has a .NET Framework library on NuGet.org who wants to make it target .NET 5, they'll take care of it on their end. You don't have to worry about that part. So the process we've showed you today is just for your first party or your private NuGet packages. And if you're not writing your own yet, honestly, there's no better time to get into it because the process is not only much easier than it was when NuGet came out 10 years ago, but there's also tools like this that are here to help you do it just as fast as you would spend time searching for one that you feel comfortable using off the gallery. And I had one question come through, and it asks if Inedo is SaaS or something I install. Okay, no, we are not software as a service. We are dedicated to being self-managed, and we are Windows primary, but you can use our products on Linux. But we commit ourselves to self-managed because we want you to use our tools the way you intend to use them. So we are 100% self-managed at this time. But as you saw, you can use a SaaS tool to create it. So I did have mine hosted today on Lightsail, which was through AWS. But if you have other questions, because I don't see any others coming through yet, if you have other questions, I invite you to contact me or my developer evangelist colleague, Carl. My email is lcamacci@inedo.com, and Carl can be reached at kharnagy@inedo.com as well. So today in our time together, we talked about how Inedo, we found 5 methods for migrating your NuGet packages, and only you and your team can pick the best ones for your private NuGet libraries. But no matter what you pick, semantic versioning is an absolute must. And to automatically enforce semantic versioning, use repackaging, which is what you saw today in BuildMaster and ProGet. The premiere of .NET 5 is a great time to onboard DevOps automation tools because they help solve your .NET migration problems, and they help you take on a faster way to do your work more reliably over the long term and in the future going forward. So on behalf of the Inedo team, I want to thank you for coming, and I will wish you a very smooth .NET 5 and NuGet migration. Thanks for coming.